Now that we've talked about solving all various equations, now I'm going to dive into inequalities. So remember, an inequality statement uses greater than or less than, all right? And when we're talking about just solving a basic linear inequality, we're talking about putting it on a number line. So whenever I say graph it, I mean put it on a number line for me. So again, remember, greater than means an open circle. You don't want to include that 4 in the solution, and you're going up from it. But if I say greater than or equal to 4, remember that is your closed circle because you do want to include that value of 4. So again, very important to know the difference between open circle and closed circle. And then of course which direction it's facing, if it's going up because it's greater than or going down because it's less than. So let's just take some time to explore solving some of these basic inequalities. So you solve them almost the same as you do equations. So I want to get x alone, so I'm just going to subtract 6 from both sides. So here x is greater than -3. So because it's strictly greater than means I don't actually want to include the -3, so I leave an open circle. And x is greater than that, so I need to be going greater than, which means towards the higher numbers. You can also do two-step ones. So in this one, I can subtract the 3 from both sides, and then divide by 2. So x is going to be less than or equal to 6. So less than or equal to, that means I want my closed circle. It means I want that 6 included in my solution set. And I'm going to face it like that. Our next one. So here now I see my variable on both sides, okay? So my variable on both sides means I'm going to subtract off the 2x from both sides to get 2x plus 5 is greater than -1. Now subtract 5 from both sides. -1 minus 5 more is going to be a -6, and divide by 2. So here, my value is at -3, an open circle, because it's strictly less than. I don't want to include that -3. And less than is going to mean it's facing the negative values. All right, the next one, same story. I need the x's on only one side, and I always encourage you collect it to the left-hand side. So I'm going to subtract x. So I'm going to get x is greater than or equal to 3. Greater than or equal to means I need a filled in circle, a closed circle, and greater than means going up. So there are the basics of what we're talking about. Now there is one little thing that you need to remember, okay? So don't forget what happens when you multiply or divide by a negative. Okay, it means you have to flip the direction of that inequality. And the other piece to this is also easiest if you collect the variable on the left-hand side, okay? I already kind of commented on this, but I think it's worth saying again that you want to make sure you're collecting it on the left-hand side. So I'm actually going to scoot this up so I have a little bit more space. But when I say collect it on the left-hand side, what I mean is even though it seems counterproductive, I'm going to subtract 3x from both sides. So that's going to give me a -2x plus 10, and that's going to leave a 0 over there. But that's okay, because what I'm going to do is I'm going to move that 10 over. I'm going to subtract the 10, and now I'm going to divide by -2. So when I divide by -2, I'm going to get x and +5. But you also have to remember, because I'm dividing by a negative here, I'm actually flipping the direction of the inequality. So now it's going to read x is greater than or equal to 5. So I go to 5, the or equal to means it's going to be a filled in circle, and then greater than that is going to point it upward. So there's all the basics on solving and graphing inequalities. Now, another skill set you're going to want is inequality word phrases. So can you take statements and turn them into inequalities? We've practiced this with expressions and equations, so this should be kind of a natural step. Now, the thing you want to make sure you understand is trying to equate it to thinking in terms of greater than or less than. So for example, n is at most 8. So if it can be at most 8, okay, that means it could be 6, it could be 7, it could even be 8, but it can't be anything greater than 8. So being at most 8 basically means n is less than or equal to 8. And when you write it like that, now it's going to be much easier to write your statement. Okay, so some of the language can get a little bit tricky. So again, it may help you to kind of reverse your thinking of it. Think of it in terms of less than or greater than. So the sum of x and 2 is at least 9. So the sum of x and 2, sum means addition. So the sum of x and 2 is at least 9. So that means it could be 9, but they could be 10, 11, so on and so forth. You're getting bigger. So being at least 10 is really meaning greater than or equal to. So I would end up writing it like that. The product of 4 and y is no more than 50. So product is talking about multiplying. So the product of 4 and y is no more than 50. So no more than 50 means it could be 48, 49, those aren't more than 50. It could even be 50 because 50 isn't more than 50, but it can't go any bigger than 50. So this is less than or equal to, if I'm equating it into more common language. So 4y has to be less than or equal to 50. All right, the quotient of 5 and the sum of y and 3. So quotient means dividing, sum means adding. So the quotient of 5 with that sum is strictly less than 10. So that one, the language was a lot easier to work with than the first ones because it was a little bit more complex to actually write the expression itself. So as always, thank you for joining me for this. Make sure you have all of this written down, and then you may move on to begin working on that worksheet.